Good morning, everyone. I'm Pavlo Burda from Eindhoven University of Technology. And today I'm going to talk about our work on improvement of early phishing detection methods by means of textual and visual features. So jumping straight into an example, here we have a phishing attempt that tries to imitate Microsoft Office services. And I'm trying to convince you that these attempts are getting even more sophisticated than, for example, only the spare phishing ones. So in this case, if we wanted to analyze the page in order to perhaps block it from reaching it, the final user, we can look at the URL, but if the URL is not in a block list, for example, there is not much to do than to look at the page. And in the page, there is no reference to Office 365. I'm talking about the source code or the document object model because no textual references are in there. And the whole layout of the page is one big image. So there are no logos isolated in the DOM that one might perhaps look at in an automated way, of course. So there are also other things like, as already mentioned, the unknown URLs and the fact that attackers use evasive techniques like randomizing domains or changing them in a fast manner. And also phishing, mass phishing has been attempting to bypass two-factor authentication and also mass phishing that is personalized towards the victim is possible as well. And this is still an open challenge for the kind of early detection methods, the one that try to block as soon as possible these new and unknown phishing attacks. Um, Indeed, the current methods are not that fast enough, for example, and some of them are not accurate enough. Like, for example, the block list. And yeah, for example, these are the methods for the early phishing detection divided in three classes like list-based, heuristic-based, and visual similarity-based. So the first one is about having a block list or an allow list of URLs and matching those URLs in order to block a page. But the limitation of this is that the URLs have to be known in advance. This is the case, for example, of um, Fish Tank or also perhaps Google Safe Browsing. But URLs, but phishing websites can also be hosted on compromised websites. So matching URLs that are benign is it's not useful here. Another set of techniques that may detect unseen attacks is a set of heuristic rules that can match potentially attacks that are unknown. However, these rules need constant updates, and an example of such rule can be the presence of an SSL certificate in for a website. But the fishers also started long ago actually to implement to use SSL certificates as well. So these things has to be updated. And in general, attackers can act on different features that are invisible to the heuristic rules and are visible to the end user. And finally, we have the visual similarity-based methods on which we focus on in this work. That consists of using the visual parts of the web page in order to compare, for example, with the visual elements or the domain of the legitimate pages in order to understand if that page, which is unknown again, tries to imitate somebody else. And with this respect, this method can detect unknown attacks because there is no list, block, or allow lists, and no fixed rules in that sense. And however, it is based on its capability to identify the legitimate corresponding websites, since there are no allow lists. And in this case, researchers have proposed to use search engines like oracles, with the assumption, of course, that search engines place the legitimate websites at the top, um, in the hope that the legitimate ones are more popular than the phishing ones. And also this depends on the features that are used as search terms. For example, and in this case, textual features and images from the document object model of a page. However, there are some evasion techniques. Again, as I mentioned before, there could be no brand reference in the source code of the page, and also even if there are logos embedded in it, those can be also splitted or generated with CSS and another techniques like the Microsoft phishing attempt I talked about before. So with this in mind, we in this work we address the what are the features that are going to be fed to the search engine, and the question would be, so does the use of visual features of a rendered web page will improve the automated identification of web pages for phishing detection? And in this approach, you can see uh, we pick, let's say, a current page as an input. So we have its URL and we have the page with its DOM, and we make a screenshot out of that. And with some magic, we extract the textual and visual features of the page. We then feed them into the one of the search engines, most popular ones, and we have a list of top results that we're going to keep to try to match against the unknown page. And from there, we can go two ways. We can first match the domain contained in the URL with the domains of the associated pages. And if that domain matches, we can deem the page as legitimate because, for example, it's in the SSL certificate of that page. And otherwise, if the page is still unknown, we retrieve the screenshots of the associated pages. And then, in order to see if that unknown page is trying to mimic one of the associated pages, we can try to compare the screenshots of the two. And if there is enough similarity, so we have a Office 365 associated page with the real domain, but the domain of our previous example is different because perhaps it's phishing, we get a high similarity score, and depending on that, we can get a feedback as an output of this method. And let's see how do we extract features. So we have this current page as our input, this unknown page, of course, and we perform some steps, like for example, a threshold algorithm to retrieve the most contrasting elements in the page. Because the elements with the low contrast are deemed in general not too much visible on the page, so they are kind of not user friendly. So websites wouldn't place logos that are not very well visible. Second, we perform some other steps, with the most important being this morphological closing, which means separated areas are meshed together to a degree such that we can isolate relevant entities, for example, the words here or boxes or logos. And this way we can pinpoint the relevant regions of a web page that may contain interesting information. However, you can see here that not all the regions are relevant, so we need to filter them. And to do that, we can act on the properties of those regions. The most straightforward property is the size of those regions. So, for example, small size or small height elements are most probably text. So we are going to exclude them in this way. Also, the number of colors is a good indicator for excluding regions. So if there are too few colors, like in black and white text, we can exclude those. And if there are too many colors, like in photos or pictures, we can exclude those as well. And the difference is tangible because black and white text usually has tens of different shades of colors, and the pictures have thousands of, actually tens of thousands, while logos are in the middle. And also another important feature is the dominant color, let's say, which is typical for logos because they tend to be vectorial in general. And also the coordinates on the page help in that, because nobody would place a logo. I mean, it's not common to find logos on the, for example, left bottom part of the page. And using this filtering strategies, we can reduce the amount of regions to search on the search engine. So what we do is extract these visual regions. We extract also the textual features, and by textual features, I mean the title HTML tag, as suggested by previous work. And those features are used as search terms on a search engine, specifically Google, with the goal of identifying the website potentially phishing web page is imitating, and to identify also the corresponding website of a benign non-phishing web page. And here we evaluate the accuracy of this method in identifying the corresponding web page with two types of features. And to do that, we build two data sets, one benign, let's say one legitimate, and one about phishing pages, from notable sources like OpenFish, PhishTank, PhishStats. And for the benign pages, we use a crowdsourced repository of legitimate pages, the dmods database, as an alternative to Alexa Top Million, because Alexa Top Million contains almost only popular pages. And you can see on the right hand side the distribution also of the phishing pages for reference. And this dataset is available at the URL below. So what we obtain here is that we are able to identify the phishing and respectively benign websites with different accuracy depending on what features are used. For the textual and visual cases, like textual only or visual only features, we obtain moderate accuracy, but combining them, we obtain 99.2% and 92% for benign accuracy of identification the targeted websites. Of course, there is a trade-off between the numbers of regions that are filtered and the accuracy, but also with the performance of such a method. For more details, you can check out the paper of different strategies and what they concern. And after this identification of targets, we also evaluated the impact of adding visual features to classify websites, classify them as phishing or not. And to do that, we used, for image comparison, we used 6 different algorithms, for which you can still see the paper details. And the best one performed as follows. For the text-only features, we obtain a moderately high accuracy, while using only visual features, we have not so good accuracy. However, using both of them, we actually have a good figure with a good improvement from text only. And by good improvement from text only, I mean a reduction of 67% of false positives and false negatives. And this difference is actually not visible here due to space constraints, because it's small from the point of view of a ROC curve. So maybe you can check out those in the paper as well. So, but the important takeaway in this case is that the approach of text only has been used before, which is one of the best performing ones. And if we apply on this previous work our more recent data set, the previous methods perform worse. And what we obtain here is that there is a positive impact of using visual features on top of the textual ones, and which is comparable to the state-of-the-art solutions, and also has some bonuses, like, for example, the language independence, so it can be done for any kind of language and website. And the 67% reduction in error rate, it's very useful if you have users, let's say, that use this method, and which are more happy to have only potentially only 3 erroneously flagged website than 10. And this makes a big difference from a usability perspective. And we also can see that the region properties can be still tweaked a lot in order to increase performances. And there are some strategies of filtering regions that do not drop accuracy, not even a percent, let's say. And with this in mind, for the future work, we actually already started to develop an anti-phishing browser plugin, and we're going to test that out with performance and usability evaluation. And that's all. Thank you for your attention. And if you're interested in the dataset, you can find it on the slides. Thank you.